Dear colleagues, my name is Andrey Tumanin, and I'll present to you the major changes and updates of C3D Modeler component. First of all, I will give you a brief overview of C3D Modeler. C3D Modeler is 3D geometric kernel. The C3D Modeler uses a boundary representation as a primary representation of modeled object. At the same time, a polygonal representation is actively developing in our kernel. The base of C3D Modeler kernel are methods of curve modeling, surface modeling, and solid modeling. In addition, C3D Modeler provides direct modeling, polygonal modeling, and unique sheet metal modeling capabilities. Finally, our main value is our team, with more than 25 years of experience and high level of expertise in geometric modeling. Some words about the latest major trends in development of C3D Modeler kernel. Recently, the importance of direct modeling has greatly increased. Considering the importance of this theme for us and our customers, a separate report on direct modeling will be presented today. There is a stable increase in the number of requests to C3D Modeler kernel for polygonal modeling. Operations for processing polygonal objects are required, as well as reverse engineering tools. The theme of polygonal modeling will also be presented today in separate presentation by my colleague. Translation from other data formats results in loss of accuracy and some defects in models. Operations with such objects require both the development of tools for diagnostic and repairing of geometry, and the support of controlled accuracy of operation on such objects. Next, the trend towards a more complex surface and solid modeling continues. There is a request for development of functionality that is not specific to traditional CAD systems. Examples of such requests for computer-aided engineering: the operation of constructing a mid-surface based on solid model and extracting a beam model from a solid model. A separate and very important point is that all these areas are extremely important for our customers, and the development time is very limited. Next, I'd like to present the most important changes in curve modeling. We completed work on curve extension functionality. Also, we implemented curve wrapping-unwrapping methods. We added accuracy control to curve-to-NURBS conversion method. And now, construction contours method takes into account tolerance at the vertices. One of the key novelties of curve modeling is the method of constructing a smoothed approximation from a set of points. The control parameters of the smoothing method are the maximum deviation of the spline from the points, the possibility of fixing it at selected points, as well as fixing the tangents at these points. Using the example of an aviation profile and a plot of radius of curvature, the effect of the smoothing is shown. The NURBS on the left passes exactly through the points. There is no smoothing. The plot of the radius of curvature with oscillations. On the right, smoothing is turned on, and as a result, the resulting curve has a higher quality. At this moment, the main position in our plans for development of curve modeling is a beam extraction tool for our CAE customers. Consider changes in surface modeling methods. First, we have improved calculation of high-order derivatives of a variable conic surface. Next, we have optimized the surface extension method. Work continues on the surface patch operation with mates at the boundaries. Next, we are consistently increasing the capabilities of the median shell operation. Also, accuracy control of surface to NURBS conversion operation has been added. We have significantly optimized the NURB surface conversion operation itself. Finally, a completely new operation of fillets group of unconnected faces has appeared in C3D Modeler kernel. I will consider this operation in more detail. The algorithm for constructing the surface of a conic section has been improved to create fillets of faces groups using the disk motion method. The disk moves along the reference curve, touching two groups of faces. The operation requires some kind of reference curve. The reference curve can be a composite curve, and they can also be closed. The radius of the fillet surface can vary linearly according to a cubic law, according to a given curve law. Various operations are available for processing the edges of fillet surface. Also, optionally, the fillet surface can cut the reference faces along the reference curves and can also be stitched to them. Briefly about the plans for the development of surface modeling in C3D Modeler kernel. We are planning to finish the fillet group of non-connected faces. Next, planned activity is extending a surface according to a given type. Median shell based on two arbitrary faces is also planned to develop. Already in develop a method for unwrapping a surface of double curvature onto a plane. Activities will continue along patch shell with boundary mates. Let's move on to the review of work in solid modeling. Over the past year, significant changes in solid modeling have affected the following operations: contour diagnostic for self-intersection in sweeping operation. Also, we have added a support of wireframe generatrix in sweep operation. The function of finding the nearest body for extrusion operation has also been improved. Next, a new operation for editing a solid body has been implemented with given a slope relative a given direction to faces adjusted to selected continuous chain of edges. The slope operation itself has been significantly improved. At the moment, the functionality of the operation of constructing kinematics with a dynamically changing section along the trajectory is in progress. The law of variation of section parameters is determined through user-specified functional dependence. The main development plans for solid modeling. Developing will continue on precision control in common operations. We also plan to complete the development of variable section sweep operation within a year. In conclusion, I will note some general or systematic work on the kernel. We continue the transition to new interfaces. Implemented embedding a progress indicator in kernel operations provides the ability to cancel the operation. We continue work on third safety of topological objects. Also added C3D format license protection, unification of C3D containers with STL, and processing of color attributes and visual effects. Also added color conversion interfaces. Finally, we added 3 new subtypes of generic attributes, array of integer values and double values. Thank you for attention.